Dear students, welcome to the course of Control System Engineering offered at Electrical and Computer Engineering Department. Hope you all are doing very well and wishes good health for your family members in this pandemic of coronavirus. I am Narayan Longani, your course instructor for Control System Engineering. Dear students, starting with lecture 1, this lecture is basically about introduction to control system and the reasons why this course is included in your course outline. In real life, you may observe many physical systems which are performing their operations, and thoughts may come to your mind that what are the rules and what are the principles are being followed by these systems. Basically, you will explore what are the principles or laws and what is the equation which is being followed by these systems for their operations. Okay students, starting with CLOs or course learning objectives. As I said in previous slide that we will observe the physical systems and find out what is the principle or what is the key equation being followed by this system. This course of Control System Engineering will be covering total 5 CLOs, CLO1 to CLO5. Starting with CLO1, CLO1 deals with to develop a mathematical model for different physical systems. As I said earlier, the physical system will be following certain rule of equation. In this CLO, basically we will try to find out the mathematical model for a physical system. In this course, we will be dealing with continuous time systems and will do analysis in continuous time domain or frequency domain. In CLO2, we will do frequency domain analysis with the help of Laplace operator, and we will develop transfer function with the help of Laplace transform. And for time domain analysis, we will do state space modeling of the differential equation developed in CLO1. You will be familiar with ordinary differential equation and transfer function in previous courses. Now in CLO3, we will do time domain and steady state error analysis, and we will study these things in upcoming chapters. CLO4 deals with stability of the system. We will find out how to check whether a system is stable or unstable. After completing CLO1 to CLO4, now turns CLO5. In control system problems, there are certain set of conditions which are given. You will get familiar with these in last chapters. What are these the problem? There are certain requirements set by a user that a system must perform these functions or achieve these targets. If you have reached the transfer function of the system from ordinary differential equation and your system is stable, then you will check whether your system is fulfilling given requirements or not. If your system is fulfilling the given requirements, then you are fine, you are done with the task, and if not, you need to design a controller to fulfill the given condition. Dear students, coming to the book affairs, we'll be using Control System Engineering by Norman S. Nice, 6th edition as our textbook, and for reference purpose you can use Modern Control Engineering by K. Ogata or any other which sounds suitable to you. Some familiar terms of this course are: your course title is Control System. This is a course of 4 credit hour. in which you will be dealing 3 credit hours for theory purpose and 1 credit hour for lab. Your course code is EEE 345 and prereq of this course is Signals and Systems. Moreover, students, your books Control System Engineering, Modern Control Engineering and your course outline are being uploaded on CU Online for your help. You may visit these books and course outline to study the upcoming topics for your convenience. Dear students, now coming to assessment plan. Assessment plan for online course is a bit different from the regular one. Okay, the internal marks in previous plan were divided among quizzes, assignments and sessional, where for online one, these marks are divided among 2 quizzes and 3 assignments. Okay, these are the minimum number of quizzes and minimum number of assignments. Minimum we have to conduct 2 quizzes and collect 3 assignments. And as earlier, final marks is again of 50%. Dear student, now we will formally start lecture 1. Starting with the contents of lecture 1, we'll start with definition of a system. We'll study what is a control system. Then further we will study what are the types of control system or how control system is implemented. Basically we have 2 types or we have 2 configuration. First one is open loop system and second one is closed loop system. We will study in detail about open loop and closed loop system and their implementation. Next we have types of input signal used throughout the course. What types of input we'll be using on various types of system. And the last one is flow diagram. That will be a flow diagram of our course. In what flow we will be moving from start to end of this course. Students, starting with system, any set of components that accept input, process it and provides output is known as a system. Like any object, any set of component which you gave input, on application of input, system performs certain operations and provides us output is known as a system. Look at figure 1. We have a system with input R of t and output C of t. This is a simple representation of a system. You will have studied example of amplifier. Let us consider an example of an operational amplifier or a simple amplifier which gives us an amplified output. You provide an input signal of 2 volt and you receive an output signal of 6 volt. This is a simple representation of a system. Further, a system can be combination of various subsystems. If you see figure B, where a system consists of 3 subsystems and input is R of t again and C of t is output. For this you can consider an example of a robot which is an electromechanical system which consists of some electrical parts and some mechanical parts. In mechanical parts, it has driving part which performs some movements and electrical part is we have actuating circuit. So a system can be a combination of various subsystems. In upcoming slides you will see an example of a robot where you can clearly see it consists of mechanical parts and electrical parts. Students, now coming to control system. Control system is simply defined as applying a desired input to a system and obtaining a desired output from a system. For this purpose, the desired output or required output is applied as a desired input to a system, to which system responds and system output reaches the desired level. If you see a figure which is the output graph of a system where a step input is applied, and as we know that step has an amplitude of 1 and step response must reaches the value of 1. If you see the graph, the output C of t starts from 0 and reaches to the final value of 1. So in this scenario, desired input is applied, which is step input, and desired output is obtained, which is a step output. So this is an example of control system. Okay students, now coming to some basic parts or components which we'll be using throughout the course. First one is plant, second is sensor, and third is controller. Basically these all are systems which accept input, process it, and give us output. Starting from a plant is a system which we want to be controlled or from which we want desired output. Second one is sensor. Sensor is actually used to measure the output and to monitor whether our system is moving to desired output or not. Last one is controller. Okay, controller is a basic component which provides desired signal to the plant for desired output. Now coming to configuration of control system. A control structure is implemented in two ways. First one is open loop system and second one is closed loop systems. Open loop systems. Open loop systems are type of systems in which output is not monitored by the system. If you see the diagram, you have an input, controller, control signal, process or plant, and output. It means the system has a predefined operation against any input. You apply the input, controller process it, generate a control signal, and give it to the plant, and plant or a process generates the required output. In this type of system, output isn't feedback to the controller or is not monitored with the help of sensor. So we are not sure that whether our system is following the desired output or not. Next we have closed loop systems. These are the systems in which we monitor the output with the help of sensors or measuring element. These are the systems in which output is measured with the help of sensor or transducer or any measuring element and feedback to the system. Before controller, an error is generated between desired input and output of the system, and then according to the error, a control signal is generated by controller, and this control signal is applied to the process or plant. If this error is increasing, which means the difference between desired input and system's output is also increasing, so a closed loop system is not performing as per requirement. And if this error is approaching to zero, which means that your system output is also approaching to the desired output. Let us have a few examples of open loop and closed loop system, starting with an example of washing machine. For cleaning of clothes with detergent, water and clothes, we just rotate the knob and wait for clothes to be clean. When the time is up, we check the clothes whether the clothes are clean or not. This is an example of open loop implementation, that whether our clothes are clean or not using washing machine. What if we add a few sensors in the washing machine that will monitor or measure the level of cleanliness? And machine will be running till that desired level is achieved or not. So now after this will become a closed loop system, which will make sure that required level of cleanliness is achieved. Under this topic, next example we have is of a moving car. Consider a conventional car which is without cruise control or speed control system. In a conventional car, for desired speed to be maintained, we press accelerometer and monitor the speedometer. Now, if we want to move the car at 30 km per hour, as per requirement, we press accelerometer and cars reaches the desired speed. And after this, we maintain the same pressure on the accelerometer. Now if after the distance of 10 to 15 km, car reaches an uphill road, as the same pressure is maintained and now car is moving on an uphill road, so automatically its speed will be slowed down, but it is required to maintain the speed of 30 km per hour. But in actual, car will be moving with a speed lower than 30 km per hour. And if the car reaches to the downhill and with the same pressure on accelerometer, the car will move with speed greater than 30 km per hour, because we don't have a cruise control system which will be monitoring the speed of the car. Now we have a car with cruise control system. Now we set a desired speed of 30 km per hour. Now if we have a plain road, uphill or downhill, the cruise control will automatically adjust the speed of a car to 30 km per hour. So now this will become a closed loop system. Okay, now we'll study comparison of open loop systems and closed loop systems. As studied earlier, open loop system don't have feedback path where closed loop system monitor the output of the system, which means open loop system have predefined operation. In comparison of these both configurations of system, first one is stability. As said, open loop system have predefined operation, so for any specific input, open loop system will perform respective operation. And for closed loop system, you have to determine whether your system is stable or not. In moving a system from open loop to closed loop, there exists a possibility that a stable open loop system may be transformed into unstable closed loop system. So every time in this conversion we have to determine the stability of closed loop system. Further about this we will discuss in the chapter of stability. Now second one is memory. As we know that in closed loop, output is determined with the help of sensors or any measuring element and requires comparison. For this, some memory elements may be required to store the information. Where in open loop system, you have input applied to the system and you get output. Where in closed loop system, you require comparison. For this, you may require memory elements. Last one is external disturbance. In open loop systems, there exists possibility that some unwanted signals may get added to the system and affect the performance of system. Where closed loop system show robustness towards unwanted external signals which are disturbance signals. In detail about this disturbance signal we will study in chapter of steady state error. Students, now we will study the course flow. In this course, whatever problem is given to you, you will start from mathematical modeling and try to find out differential equation of the system. Now, if we are analyzing our system in frequency domain, then with the help of Laplace operator, we will find out transfer function of the system. And if we are studying time domain analysis, then we will find state space model of the system. After transfer function or state space model, we will compute stability of the system and find out that our system is stable or unstable. If our system is stable, then we will find out time response specifications, which include transient analysis. And after transient analysis, we will study steady state error specification of this response. After step 1 to 5, we will check that whether our system is fulfilling given set of conditions or not. If time response specification meet the given set of requirement, then we are done here. And if certain changes are required, then we'll have to design a controller for a system. And also, if our system is unstable, then we have to design a controller for this system. This is the whole flow of the course, how we will start from mathematical modeling, transfer function, state space, stability, time response, steady state error, and at the end we'll design controller for a system. Students, now we'll study various test signals which we'll use throughout this course. These signals will be applied to a system and certain time response specification and steady state error specification will be checked. Many of you will be quite familiar with these input signals. In the series of input signal, first one is impulse signal. Impulse have an area of 1 and graphical and mathematical form are given in this table. This signal is used for testing transient response modeling. Second one is step signal. Step signal is represented by u of t and its magnitude is equal to 0 for time less than 0 and magnitudes equal to 1 for time greater or equal to 1. And this signal is used for transient and steady state error modeling. Third one is ramp signal. Ramp signal is basically integrating a step signal. This mathematical model and graphical representation is given here. Ramp signal response also exists for time greater or equal to 0 and for time t less than 0 its response is equal to 0. In this sequence, third signal is parabola signal, which is used for steady state error analysis. Parabola signal is like integrating the ramp signal. Last we have is a sinusoid, which is used for transient modeling and steady state error modeling. Mathematical form is given in the table. Now if any of you have any questions, please ask.